like you guys want to be here. So you guys ready? Loud and clear. Class.
Yes.
Tree. Okay, all right, good. All right, so we're going to go through and do a little bit of more complicating of math. So right here, using logarithmic differentiation, go through here, simplify properties using logarithms. Step 2, differentiate implicitly. Use the fact that dy dx of ln y is equal to y prime divided by y. Solve for y prime and replace with f of x. Now, isn't that what we just did on that last problem? Say yes.
Yes.
Yeah, we just did that on that last problem. But now, see this right here? This is super crazy. That's Googling Google. X to the x. Right? Okay. So we are going to needlessly complicate, actually needfully complicate this. Let's ln both sides because I like natural log. ln is, pretty straightforward. So I'm going to ln, so it's ln of y is equal to ln of x to the x. Now what can I do with that x? This x in the exponent. What did we do with it yesterday? Bring it to the front. So now I'm going to have ln of y is equal to x times ln of x. And now let's go ahead and take the derivative. The derivative of ln y is derivative of ln y.
1 over y.
1 over y, very good, but still missing?
1 over y times dy over dx.
Dy dx, perfect, good job. 1 over y dy dx is equal to, now there's a reason why I put that dot right there. I put that dot there to say that that is a, very good, a product rule. So product rule, let's go ahead and do this. So f prime is going to be 1, right? 1 times ln x. Product rule is a plus sign. X times, what's the derivative of ln x?
1 over x.
1 over x. All right, let's clean it up a little bit, because right here, it's going to go there. So now, I'm going to have 1 over y dy dx is equal to ln x plus 1. And see how I got the plus 1? Because over here my x's cancel, right? Okay, it's almost there. What do I have to do with that 1 over y now? Multiply by y, so let's do that. So I'm going to multiply both sides by y, so I get dy dx is equal to ln x plus 1 times y. Can I leave that y there? Say no. Why? I don't know. What is y?
It's a variable. Oh, okay. Oh, okay. It's x to x.
Right? And so instead of actually having it y, because I want the derivative in terms of x, that means I don't want y's in my problem. So since I know what y is, I could sub it back into this so I won't have any y's in my answer. So my final solution is dy dx is equal to x to the x times ln x plus 1. Yes? No? Maybe. Possibly. Are we okay with that now? Are we happy?
So happy together.
Find the equation. Find the equation of a tangent line to the graph here at the point there. Alright, so I know the x and the y, and if I want the equation of a tangent line, what do I need? I need to find the derivative, right? The derivative where? At 1, because I'm only going to plug in the x, right? So I'm going to plug in the x. So I could do this a couple different ways. I could look at it and be like, oh, look, there's a product on top and it's a quotient altogether. I could do all that, or I could ln again. So that's what I'm going to do. I'm going to ln everything first. Remember, if it's a multiplication here, what type of ln is that? What am I going to do with my two ln's? Because I am going to break it up.
It's
Addition, very good. And the division means it's going to be
subtraction.
very good. All right, so let's go ahead and ln both sides. So I'm going to have ln of y, because I'm changing this to y, right, is equal to, I'm breaking everything up here. So I'm going to start with ln of, very good, ln x, plus sign, just like you said, plus sign what?
Natural log of parentheses x squared plus 3 to the 1/2 power.
Yep, very good. 1/2. And then,
Minus natural log of 1 plus x.
very good, just like that. Alright, so we can go through and start chugging along, right? So, this first one right here, this is going to give me 1 over y dy dx equals 1 over x plus, what am I doing with that 1/2?
I'll bring it up front.
Out front, very good. So 1/2 out front. And then, remember, we're going to treat this like a u, right? We're going to treat it like a u. So the derivative of ln is going to be basically 1 over u, right? So this is going to be 1 over x squared plus 3 times u prime. What would my u prime be?
2x.
2x, very good. Minus sign. Right here, this is also going to be a u, but 1 plus x, the derivative u prime is just going to be just 1. Okay, so I could just treat it just as is, so it's going to be 1 over 1 plus x. And any cleanups that I could do, I will. So I'm going to have dy dx. I'm going to multiply everything by y. So I'm just going to put the y way over here. One over x. 2's cancel there, so I'm left with plus x over x squared plus 3 minus sign 1 over 1 plus x. All this is going to be times my y. And in this case, my y is going to be all of that. That 3, it's a 3, my pen kind of messed up there. There you go. Okay. Now what do I do there? Plug in my x, right? Okay, I don't have any more y's. So if I plug in my x, this is going to be 1 plus 4, right? 1 over 4 minus 1 over 2 times, this is going to give me 4, square root of 4 is 2, times 1 is 2 over 2. A little bit of finagling here. Let's call this one 4 over 4. And this is 2 over 4. So that's going to give me, let's see, subtract, I get 2, 3. 3 over 4. Now, anyone notice? Couldn't I just plugged in my y value instead of actually doing the whole thing? What was my y value? It was 1. Didn't I already know that y is equal to 1?
Wait, so can we do that now?
You could have done that in the first place right here,
Okay.
because I already knew what the y was. Instead of actually plugging in the x for every single one of these, I got 2 over 2, which is still 1. So I get a slope of 3 over 4. Now let's check our calculator, because this says calculator. So my tangent line, I have 3 over 4 So this one should be pretty easy here. Y minus 1 equals 3 over 4, quantity x minus 1. Y equals 3 over 4, x minus 3 over 4, plus 4 over 4. So all I did is I added the 1 to both sides, but my plus 1 turned into plus 4 over 4 right there, so I can combine those a little bit easier. Now let's look at the calculator stuff. So the calculator is super smart. Let's go to the graph. And let's go ahead and graph my function that I had in the first place. So here I have my tab, right here to this, control divide is going to give me the fraction. x times square root of x squared plus 3. One plus x. Is that correct? Alright, I'm gonna hit enter. Dang, that's all craziness right there, right? So, menu. Analyze graph. Right here, dy dx. So that's gonna give me the slope at a singular point. And I'm gonna pick the point number 1. So I told it I want the point when x is 1, 0.75. Isn't that my 3/4? There you go. That's basically what I have to do there. So I could put it into the calculator, tell my calculator to give me my dy dx. At the singular point, I get the slope. So if this was a calculator problem and I asked you to do it, and you could use your calculator will give you the derivative at the point. It won't give you the equation for the tangent line, but it will give you the slope. Now, see this right here is in F1, isn't it? I'm going to go exit this. So let's go back to this one right here. And I'm going to show you this vars. This vars button right here is important. Vars, that means where did I enter my function? So this helps especially when you have a couple different problems that you're working with. So I'm going to use my first one. And f of 1, we know my coordinate at 1, what was my y value? Yeah, there you go. F of 1 is 1. So you could use this to find any y values that you have also. Make sense? Now, there was a problem, Juju, what was that problem we were working with yesterday? That it was like super complicated and we had to get an answer of like 2 or something like that. Like an answer of 3. I remember I did it in pen.
Was it the slope of the normal line?
Yeah, I think that was the one where we actually had to find the x values. We knew that the y value was something. Oh, I kind of remember it. So it was like x squared or x cubed. Yeah, it was x cubed. That's what the problem was. Plus 2x. Something like this.
Yeah.
Okay, so right here, I'm going to put in the graph and enter it. And what was the value it was supposed to equal? 3, right? It's because it gave me the y value of 3, right?
Yeah, we're trying to find g prime of 3 and g prime of 0.
Okay, so my y value is 3. So I could just go tab, and my y value is 3. I just put that in as 3. And I look to see where these two lines intersect. Menu. Intersection. So when you get to those problems that are really difficult to try and factor or even solve for, plug them into your calculator, see what you can get from the graphs also. This is another way of trying to solve these problems. Yes? Christian? Okay. Alright, how many more slides we got? 3 more?
4.
Alright, so do you know what that means? It's enough to do it, finish later. So make sure you guys all like, share, and subscribe.